Good morning everyone. Today we are going to discuss the first chapter in plus 2 mathematics textbook, that is nothing but relations and functions. Okay, ഈ ചാപ്റ്ററിലേക്ക് നമ്മൾ പോകുന്നതിന് മുമ്പ് നമ്മൾ ഫസ്റ്റ് ഇയറിൽ റിലേഷൻസ് ആൻഡ് ഫങ്ഷൻ എന്ന് പറയുന്ന സെക്കൻഡ് ചാപ്റ്റർ നമ്മൾ പഠിച്ചിട്ടുണ്ടായിരുന്നു. ആ ചാപ്റ്ററിൽ നമുക്ക് ആവശ്യമായിട്ടുള്ള കുറച്ച് ബേസിക്സ് ആയിട്ടുള്ള കുറച്ച് കാര്യങ്ങൾ പറഞ്ഞിട്ട് വേണം ഈ ചാപ്റ്ററിലേക്ക് പോകാൻ. ആയതുകൊണ്ട് ആ ചാപ്റ്ററിൽ എന്തൊക്കെ പഠിച്ച കാര്യങ്ങളൊന്ന് ഞാനൊന്ന് റിപ്പീറ്റ് ചെയ്യാം. ഓക്കെ, ഫസ്റ്റ് നമ്മൾ പറഞ്ഞു എന്താണ് സെറ്റ്. സെറ്റ് ഈസ് എ വെൽ ഡിഫൈൻഡ് കളക്ഷൻ ഓഫ് ഡിസ്റ്റിൻക്റ്റ് ഒബ്ജക്ട്സ്. Okay, an example, A equal to set 1, 2, 3 is. Similarly, we know that set of all natural numbers, set of all integers, set of all rational numbers, set of all real numbers. Okay. പിന്നീട് നമ്മൾ പഠിച്ചു what is a Cartesian product or cross product of a two set. Okay, A എന്ന് പറയുന്നത് സെറ്റ് 1, 2, 3. അതുപോലെ തന്നെ മറ്റൊരു സെറ്റ് ഉണ്ട്, സെറ്റ് B ഈക്വൽ ടു സം 4, 5. ഓക്കെ, അങ്ങനെയാണെങ്കിൽ നമ്മൾ A ക്രോസ് B ഈക്വൽ ടു is equal to it is equal to set of all x, y such that x belongs to A and y belongs to B. Y belongs to B. This is the definition of a Cartesian product or cross product. Okay, in this particular example, what is a Cartesian product? Okay, we know that this one is a ordered pairs. 1, 4, ordered pair 1, 4, ordered pair 1, 5, ordered pair 2, 4, ordered pair 2, 5, next ordered pair 3, 4 and ordered pair 3, 5. Okay, ഇതാണ് Cartesian product of set A and set B or cross product of set A and B. Okay, ഇനി നമ്മൾ അങ്ങനെയാണെങ്കിൽ എത്ര കാർട്ടീഷ്യൻ പ്രോഡക്റ്റ് പോസിബിൾ ആണ് എന്ന് നമുക്ക് നോക്കാം. അതായത് I have a set A with cardinality of A. Cardinality of A എന്ന് പറഞ്ഞാൽ n of A. A എന്ന് പറയുന്ന സെറ്റിൽ m എലിമെൻസും അതേപോലെ തന്നെ കാർഡിനാലിറ്റി ഓഫ് B, ദാറ്റ് മീൻസ് n of B. n എന്ന് പറയുന്ന സെറ്റിൽ B എന്ന് പറയുന്ന സെറ്റിൽ ഉള്ള എലിമെൻസിൻ്റെ എണ്ണം ഈസ് ഈക്വൽ ടു എന്നുമാണെങ്കിൽ, അതായത് എ എന്ന് പറയുന്ന സെറ്റിൽ m എലിമെൻസും ബി എന്ന് പറയുന്ന സെറ്റിൽ n എലിമെൻസും, അതിൻ്റെ മറ്റൊരു ഡിനോട്ടേഷനാണ് ദിസ് വൺ, കാർഡിനാലിറ്റി ഓഫ് എ, അതേപോലെ തന്നെ കാർഡിനാലിറ്റി ഓഫ് ബി. അങ്ങനെയാണെങ്കിൽ എ ക്രോസ് ബിയുടെ കാർഡിനാലിറ്റി എത്രയായിരിക്കും, അതായത് എ ക്രോസ് ബിയിൽ എത്ര എലിമെൻറ്റ്സ് ഉണ്ടാകും? ഇറ്റ്സ് എ വെരി സിമ്പിൾ ആൻസർ that we are discussed in 11th class, that is nothing but m into n or mn. Okay, or mn, yes, m into n. ഇതറിയണം. ഓക്കെ, ഇനി എന്താണ് റിലേഷൻ? വാട്ട് ഈസ് എ റിലേഷൻ? Relation is a subset of A cross B. Relation is a subset of A cross B. Relation is a subset of A cross B. A cross B യുടെ subset ആണ് relation. Okay, what do you mean by a subset? A is a subset of B if Aയിലുള്ള എല്ലാ എലിമെൻസും B എന്ന് പറയുന്ന സെറ്റിൽ ഉണ്ടെങ്കിൽ we know that A is a subset of B. If every element of A contains in a set B, then we can say that A is a subset of B. A is a subset of B. An example, if A equal to set 1, 2, 3. Okay, if A equal to set 1, 2, 3. Similarly, set B equal to some 1, 2, 3, 4, 5. See, every element of A is an element of B. 1 is there. Yes, 1 is there. 2 is there. 3 is there. Yes. Therefore, A is a subset of B. That means every element of A is an element of B. Hence, A is a subset of B. Yes. That is a subset. ആയതുകൊണ്ട് R is a subset of A cross B. Relation is a subset of a Cartesian product A cross B or cross product A cross B. Okay. Then I will give an example for a relation. Let us consider A equal to set 1, 2, 3. Set 1, 2, 3. Similarly, B equal to some 4, 5, 6. Okay. Then we can easily find what is an A cross B. A cross B is nothing but A cross B is equal to set of all ordered pair x comma y such that x belongs to A and y belongs to B. That means 1, 4, next 1, 5, next 1, 6, okay, next 2, 4, 2, 5, x, next 2, 6, then 3, 4, 3, 5, last element is nothing but 3, 6. Okay. See, A has a 3 element. A il 3 elementum, B il 3 elementum ഉള്ളതുകൊണ്ട് A cross B ൽ എത്ര എലിമെന്റ് ഉണ്ടാവണം? 3 into 3. 3 into 3 is equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay. Then, see, if I am defining R equal to relation defined from A to B, that means this denotation is nothing but relation R from A to B defined by R equal to set of all x comma y such that y equal to some x plus 3. Okay, y equal to some x plus 3. This representation is known as a set builder form of R. Okay, we can write the roster form of this R. What is that? R equal to set of all, let us give x is equal to 1. X 1 ആണെങ്കിൽ how much y? Y equal to 1 plus 3. Yes, 1 plus 3 is equal to how much? 4. 1, 4. Yes. Next, let us give x equal to 2 because relation from A to B. A യിലുള്ള എലിമെന്റ്സുകളാണ് നമ്മൾ എക്സിന് കൊടുക്കേണ്ട വാല്യൂസ്. ഓക്കെ, എക്സിന് 1 കൊടുത്താൽ 1 plus 3 is equal to 4. നെക്സ്റ്റ്, എക്സിന് 2 കൊടുത്താൽ 2 plus 3. 2, 2 plus 3. How much? 2 plus 3 is equal to 5. Next, എക്സിന് 3 എന്ന് കൊടുത്താൽ 3 plus 3. 3, 6. This is the relation. Yes, is over. See, 1, 4, 2, 5, 3, 6. Every element of R is an element of A cross B. Therefore, R is a subset of A cross B. Hence, R is a relation from A to B. Okay. This is our first year. That's what we understand. Relation is a subset of A cross B. Okay. Next, what is the domain of a relation? What is a range of a relation? And what is a codomain of a relation? നമ്മൾ x valuesന്റെ അതായത് r equal to set of all x, y such that x belongs to A and y belongs to B. അങ്ങനെയുള്ള x valuesന്റെ സെറ്റിനെയാണ് നമ്മൾ ഡൊമൈൻ ഓഫ് ദാറ്റ് റിലേഷൻ എന്ന് പറയുന്നത്. അതുപോലെ തന്നെ y വാല്യൂസിൻ്റെ സെറ്റിനെയാണ് നമ്മൾ എന്ത് പറയാറുള്ളത്? റേഞ്ച് ഓഫ് ദി റിലേഷൻ. കോഡൊമൈൻ എന്ന് പറയുന്നത് എന്താ? റിലേഷൻ ഫ്രം എ ടു ബി ആണെങ്കിൽ ഈ സെക്കൻഡ് സെറ്റിനെ ടോട്ടലായിട്ട് പറയുന്ന പേരാണ് കോഡൊമൈൻ ഓഫ് ദി സെറ്റ്. മേ ബി റേഞ്ചും കോഡൊമൈനും എന്താകാം? ഈക്വൽ ആവാം, ഈക്വൽ അല്ലാതിരിക്കാം. മേ ഓർ മേ നോട്ട് ബി ഈക്വൽ. ഓക്കെ, നമുക്ക് ഈ ഒരു എക്സാമ്പിളിൻ്റെ ഈ ഒരു റിലേഷൻ്റെ ഡൊമൈൻ എന്താണ്, കോഡൊമൈൻ എന്താണ്, റേഞ്ച് എന്താണെന്ന് നമുക്ക് ഫൈൻഡ് ചെയ്യാം. ഓക്കെ, സി ഡൊമൈൻ ഓഫ് ദിസ് റിലേഷൻ, ഡൊമൈൻ ഓഫ് ആർ is equal to, see, domain of R equal to, okay, x values 1, set 1, next 2, next 3, set 1, 2, 3. Next, range of R equal to, range of the relation R equal to set of all y values in the set. Yes, see, y equal to here 4, here y equal to 5, here y equal to 6. Therefore, 4, 5, 6. Next, what is the codomain of R? Codomain of R equal to second set. What is the second set? If R from A to B, then codomain of this relation is nothing but second set, that is equal to B. Okay, I think you guys are understand these things. First one is what is the domain of a relation, second one is the codomain of a relation, third one is the range of a relation. These three things are very important. Okay, next question. Next, I have one doubt. What is that? See, if I have a one set with, if I have a one set A with n of A, that means number of elements of A. In another way, cardinality of A equal to n. Next, if I have another set with number of elements of B equal to cardinality of set B equal to M, then we can easily say that the cardinality, otherwise number of elements of A cross B is equal to, in another way, cardinality of A cross B is equal to, we know that is nothing but m into n or mn. Okay, this is a one way, one important fact. Similarly, if I have a one set with number of elements of A equal to some S. Okay, this A and this A is not equal, don't confuse. Okay, this is some X. I have a one set X, capital X, with S number of elements. Then how many subsets are possible? How many possible subsets are there for this set X? Are you understand? Okay, I clarify my question once again. See, if I have a one set capital X with 1 comma 2, this is my set. How many possible subsets are there for this set? We know that the collection of all subset of any set is said to be power set of that set. My question, what is the cardinality of P of X? P means power set of capital X. Okay, first we need to write what is the P of X, power set of X. This is nothing but power set of X is equal to, see, okay, empty set. We know that empty set is always subset of any set. Next, set 1, singleton set 1. Next, singleton set 2. Next, all set X. How many are there? What is the cardinality of n of P of X? Otherwise, cardinality of P of X. It is equal to 4, right? It is equal to 4. See, X have 2 elements. Therefore, power set of X has 4 elements. That is nothing but 2 square. This also we are studied in first year. Okay, in another way, in general, if I have a one set X, capital X, with S number of elements, then how many elements are there? Otherwise, how many elements are there in a power set of X? That is nothing but 2 power S, 2 raised to S. In another way, how many possible subsets are there? That is nothing but 2 power S. Okay. Now my question. See, if I have a one relation, I know relation is subset of A cross B. See, if I have a one set with A equal to number of elements of A equal to n and number of elements of B equal to m, then we know that number of elements of A cross B is equal to mn. Then one more thing, if I have a one set X with number of elements of X is equal to small s, small letter s, then how many possible subsets? In other words, what is the cardinality of power set of X? Power set of X is nothing but all possible subset of capital X. All possible subset of capital X. How many are possible? 2 power S. Now my question, if I have a one set with n elements and a set B with m elements, then how many possible relations are possible from R from A to B? It's very easy. See, let us join these two results. I know R is a subset of A cross B. Then how many possible relations are possible? That is nothing but 2 power the cardinality of A cross B. That is nothing but mn. That means 2 raised to mn. My conclusion is nothing but if I have a one set A with n elements and another set B with m elements, then total number of possible relations from A to B is nothing but 2 power mn. Okay, you can, this also we have studied in the 11th chapter, 2nd chapter, relation and functions. Okay, next. Now we are discuss what is a relation and how many possible relations are possible, and we have discussed relation is a subset of A cross B. We have discussed what is a Cartesian product or cross product and what is a set. Now we can just move the first chapter of second year, that is nothing but relations and functions. In this chapter, we are going to discuss different types of relations. Different types of relations. And in first year we are also discuss functions. That is very important. And several types of functions, just like rational function, modulus function, and polynomial functions, greatest integer function, and algebra of a functions, how to add two function, how to subtract two function, how to multiply the function with constant, and how to divide the function. That is an algebra of a functions. And then we have discussed how to find the domain and codomain and range of a function. In this second year chapter relations and functions, we are studying the different types of functions and different types of relation and binary operation and composition of a function. Now we can discuss the first part, different types of relations. Different types of relation. In this part, we need to discuss the three types of relation. First one is a reflexive relation. Reflexive relation. Second one is the symmetric relation. Symmetric relation. Okay. Third one is the transitive relation. Transitive relation. Okay. If a relation, it is a symmetric, it is reflexive, it is transitive, then that type of relation is known as an equivalence relation. That is the first part. Now we need to discuss what is a reflexive relation, what is a symmetric relation, what is a transitive relation. Through one example, I will discuss what is a reflexive relation, symmetric relation, and a transitive relation. See, let us consider if I have one set A equal to set A, B, C, and another set okay. If I have a one set A, B, C, then I can define the relation. Relation is a subset of A cross B. Here I am not going to consider another set. I can define the A cross A. Now let us consider the relations are a subset of A cross A. How to find the A cross A? It's a very easy. Okay, for this particular example, how to find the A cross A? A cross A is nothing but A cross A is equal to set of all ordered pair A cross A such that A belongs to A. See? In this particular example, what is A cross A? A cross A is equal to okay. A cross A is nothing but A, B, C. No. A cross A is equal to A comma B such that A comma B belongs to A. A cross A is nothing but cross A, B, C. What is this? How to find? See, ordered pair A comma A and ordered pair A comma B and ordered pair A comma C. Next, B comma A, B comma B and B comma C. Next, C comma A, C comma B and C comma C. This is nothing but A cross A. We can define the cross product of one set with itself. That is an A cross A. Okay. Therefore, in this chapter, if I am telling a relation on A, that is nothing but this relation is a subset of A cross A. Relation from A to A. In other words, relation on A. Relation from A to A, it can be say that relation on A. Okay, relation from A to A, we can say that in another words, a relation on A. That is nothing but R is a subset of A cross A. R is a subset of A cross A. That is a relation on A. In another words, relation on A. We can easily find A cross A. And we can find one subset of A cross A. That is nothing but relation on A. Okay. Now I need to define what is a reflexive relation and symmetric relation and transitive relation. Okay. Now we know that what is a relation on A. Relation on A is nothing but relation is a subset of A cross A. Then it is known as relation on A set A. Okay. A relation on A is said to be a reflexive. Then A comma A belongs to R for every A, for all A, otherwise for every A. Then that type of relation is known as a reflexive relation. Once again, a relation on A, otherwise if a relation is a subset of A cross A, then that type of relation is said to be reflexive if A comma A belongs to R. Ordered pair A comma A belongs to R. R is nothing but relation for every A, for all A. If I have a one set, just like A equal to set 1, 2, 3, then what are the all possible pairs, ordered pairs of the form A cross A? That is nothing but 1, 1, next 2, 2 and 3, 3. If these all possible pairs are there in that type of that particular relation, then that relation is known as a reflexive relation. Understand, right? When a relation is said to be a reflexive relation, a relation on A, that means relation is a subset of A cross A. It is said to be a reflexive AA. The all possible pairs of AA belongs to R. Mathematically, the ordered pair AA belongs to R for every A or for all A. That type of relation is known as a reflexive relation. Next one is symmetric. When a relation is said to be symmetric, if, this is the first concept. Second one, if is very important. If AB belongs to R, which implies, otherwise then BA belongs to R, then that type of relation is known as a symmetric. See, if AB belongs to R, then BA also belongs to R, then it is not said to be symmetric. One example, if 1, 2 belongs to R, then it's said to be, if we need to say that relation is a symmetric, then we need 1, 2, 2, 1, we need 2, 1. If 2, 1 belongs to R, then that type of relation is said to be symmetric. If, this is very important, if AB belongs to R, then we need BA belongs to R. Then that type of relation is known as symmetric. If it is not, it is not symmetric. That's it. Okay. Third one, when a relation is said to be transitive. When a relation is said to be transitive. Okay. If A comma B, ordered pair AB and ordered pair BC belongs to R, then we need AC belongs to R, then that type of relation is known as transitive. If it is not, it is not a transitive. That's it. If a relation on A, it is reflexive, symmetric and transitive, then that type of relation is known as an equivalence relation. Okay, once again I will repeat. A relation on A. What do you mean by a relation on A? A relation R on A. That is nothing but R is a subset of A cross A. We know how to define A cross A. It's a very simple. A cross A is nothing but set of all ordered pair A comma B such that A comma B belongs to A. Then that type of relation is, that type of Cartesian product is known as A cross A. That means the cross product with a set itself, that type of cross product is known as A cross A. Okay. If a relation is a subset of A cross A, then that type of relation is known as a relation R on A. Now, we need to define three very important types of a relation. First one is a reflexive, symmetric and transitive. When a relation is said to be reflexive, a relation R on A is said to be reflexive if A comma A, ordered pair A comma A belongs to R for every A, for all A. For every. This is a mathematical denotation of for every, for all. Or for all. AA belongs to R for every A. Then that type of relation is known as a reflexive. Second one is a symmetric. If A comma B belongs to R, then B comma A belongs to R, then that type of relation is known as a symmetric. Third one, if A comma B and B comma C belongs to R, then if A comma C also belongs to R, then that type of relation is known as a transitive. If it is not, it is not transitive. Then a particular relation is reflexive, symmetric and transitive. Then that relation is known as an equivalence relation. Okay. In next class, we can discuss several examples of a reflexive, symmetric and transitive and an equivalence relation. Thank you.